Okay, log rules. Rules of log that you have to know. First, log base A of 1 is, actually this one you know. I'm just writing as a rule because often you forget. 1 is A to what power? 0th power. Anything to the 0th power is 1, right? So you have log A of A to 0, so what's this value? 0. And then B, you have log A of x times y is log base A x plus log base A y. Multiplication inside a single log becomes addition outside two logs. Now, often people misunderstand this to think that, oh, does this mean suddenly multiplication means addition? No, multiplications and additions are different, totally different operations. It just happens that log, if you have a single log and you split them into two, you end up with an addition of two logs. If you remove this to a single log, then it doesn't work. See, a common misunderstanding is that people think this is the same thing as log A of x plus y, and that's a no-no. This is not the same thing as that. Okay? You have to be very careful. Okay? Yeah. These cannot be combined like that. When you have two different things, when you combine them, it combines as a multiplication, not an addition, right? Okay. C, division inside a log becomes what? Subtraction. And D, so there's some two more weird rules. The first thing is log A of x of some constant c, some exponent. If you have an exponent inside the log, and it's really important that this exponent is inside the log. If it's not inside, then you can't do that. You can't simplify according to this rule. You can make this c jump over the log and make it like c log A of x. And this is my favorite log rule because when my son was like 5 years old, I was like reading him a picture book. No, not calculus. He will do calculus next semester. Right. Yeah, he's going to 9th grade next semester. Right. But I was reading this picture book, and the picture book had a frog over the log. Yeah, frog jumping over the log. And I was just amazed, like, this is it. This is the word I'm going to use when I teach logs to my students in school. So after that, I always introduce this rule as the frog over the log rule, because the exponent inside the log jumps like a frog so that it comes over here. That's what I call it. It's like frog over the log. And by the way, this is my own naming, so don't go telling other people frog over the log. They're not going to understand what you mean. Your tutors are not going to understand what you're saying. Right? I should trademark TM. Okay. The frog over the log rule. So the exponent inside the log, they jump over the log like a frog. And then the last rule that you have to know is something called the base change formula. Log A of B is log of B over log of A. And this is also same as ln of b over ln of a, and that's also same as log base c of b over log base c of a. And this is called the base change formula, and that's an official name. That's an official name. I didn't make the name, this is an official name. Okay, let me explain what this last bit is. As I explained when I was introducing the log, that your calculator, if you're using a scientific calculator, your calculator will only have this type of log and this type of log. What is this log without any base? What does that mean? There's a 10 missing. Okay, so this is called a common log. That's because when log was first invented by this guy John Napier, he made a table for log base 10. Okay, and then you have this ln, which is the natural log, which has the base as the natural number. So log base e of x is what we call ln of x. And because these are the only things that your calculator has, if you're using a small scientific calculator, you can't calculate like log 2 of 3. By the way, log 2 of 3, 3 is not like anything easy as power of 2. So you can only use calculator to figure this out. It's an irrational number, and it's like a decimal that does not repeat. It's very, very crazy. And the only way you can get to this number is by using your calculator, but your calculator doesn't have log base 2. So what do? You use this base change formula. You can either write this as log of 3 with base 10 divided by log base 10 of 2. So you can do this with your calculator because these are afforded by, it's in your calculator. Okay, these are in your calculator. Or you can even use your ln function. So it's a crucial, this base change formula is a crucial formula to use if you want to use your calculator to calculate. Without knowing the base change formula, you're just stuck. You can't do anything with this. If you're being asked, what's log 2 of 3? You can't solve this by hand. You can't use your calculator because you don't know the base change formula. Got that? Is that good? All right. Now, what's mysterious about this base change formula is when you first see it, it's like, what's so special about log base 10 or log with base e that you have such a formula? Well, the answer is it's not anything special. If your calculator had, say, log base 7 as the only function given, I mean, let's say somebody really likes 7, so they make a function with log base 7. Then you can use that too. So basically, your C can be anything. Your C can be anything. All right, just to give you a demonstration of this base change formula, let me revisit one of the questions that we did. A moment ago, we did log base 4 of 8, right? And we had to do some crazy manipulation, like write 8 as 4 times 2 and to get it, right? Here's a quick way to get it by base change formula. See that 4 and 8 are both powers of 2, right? 4 is 2 squared, 8 is 2 cubed. So applying log of 2 would make things a lot easier. So according to this base change formula, with C being 2, right, I have log 2 of what over what? What goes here and here? Log 2 of? Look at this formula. This is this, with C being 2. So this B goes over here, A goes down here, right? So what goes in here? Well, that's what you get if you calculate, right? 8 and then 4, right? But 8 is 2 to the 3rd power, so what's log 2 of 8? 3. 4 is 2 squared, so what's log 2 of 4? 2. That was so easy, right? It was much faster than what we did before. So that base change formula sometimes can give you the answer just like that. Okay? So not only this base change formula is important for your calculator, it's also sometimes very convenient in calculating some of the logs. Okay? these are the law rules.